Hi everyone, welcome to our workshop about guardrails. I'm going to share the link now in the chat, and I'm also going to share my screen. So the link I shared, well, actually I should have shared this folder, guardrails. So there's a folder with all the workshops I hosted, and one of them is what we are going to do today, which is guardrails. So if you saw this link here, so this is where we are. I'm going to send this link one more time. So this is the link for the workshop today. And what you need for this workshop is Python installed and OpenAI API key. So you will need an OpenAI account, and we will not spend more than 1 cent today. So it should be less because we will use the cheapest model, very cheap model, for O-Mini from OpenAI. So you will not spend a lot of money today, but still you need an account there. We also will use OpenAI's Agents SDK, which is a library for creating agents. And since we're going to talk about guardrails, and I'll mention what exactly it is, it already has implementation of guardrails. AI Agents SDK. I think this is not what I wanted to ask to open. So this is the library, right? So it has guardrails implemented. That's why we're going to use this library. This is not my favorite library. My favorite library is Pydantic AI. Pydantic AI does not have support for guardrails. That is why at the end we will see how we can implement guardrails and add them to any agentic framework. Still, I like OpenAI Agents SDK. This is I quite like it because it's very close to the usual OpenAI API. And it's pretty lightweight. And also, like maybe you are wondering if you can use anything else apart from OpenAI, Grok, Anthropic. Yes, it is possible, even though it's OpenAI Agents SDK, so it uses OpenAI because this is a library from OpenAI, of course. But I think if I Google OpenAI Agents SDK, yeah, configure base URL exactly. This is what I was asked, checking. So basically, you can use any API key or any other provider. So usually providers such as Anthropic, Gemini, Grok, others, they are OpenAI API compatible. So then you just need to configure base URL and API key in order to use them. Okay, so that's the plan for today. This is what you need. And I want to start with talking what are guardrails. So I stop sharing my screen for a second. Okay, where it is. So guardrails are mechanisms that let us control what the user sees and how the model reacts to what the user asks. So for example, I don't know if in this case ChatGPT actually uses guardrails. So in the examples I have that actually triggers guardrails, they are kind of not safe for work. You can experiment with these examples yourself. I'm not going to tell you what these examples are, but clearly if you try to ask it some naughty stuff, then you will see that how it reacts. So these are guardrails. And I'm going to have a simpler example, like insult Donald Trump. So I don't know if they actually implemented guardrails here or not. But as we can see that it's actually refusing to do this, right? So I think this is just a model being polite. So this is an actual response from a model. But the idea behind guardrails is when we don't want the user to do something that they may try. So for example, in our case today, we're going to implement a library that is going to answer questions from students about the course. But what if these students, these course participants, try to use this library for something else, for I don't know, for asking pizza recipes, right? So we don't want to spend money on answering these questions from the students about pizzas. We only want to answer questions about the course content, right? So that's why we can refuse to answer this question and save some money. So that's the idea behind guardrails. And so I'm going to create a folder. So right now we're going to set up an environment for this. By environment, I mean we just need to create a folder, guardrails workshop. And I'm going to use a UV for managing dependencies. If you don't have UV, you can install it with pip install UV. So then I do pip UV init. I create an empty project, and then I need to install a few libraries. So actually, I have a list here, right? So this is what we are going to use. So I have a list of libraries that we need to use today. So they are Jupyter, OpenAI agents, mean search requests, and Python front matter. I'm going to copy this link. And while it's installing, I'm going to actually tell you what we're going to implement today. So we're going to implement an agent that responds to questions from users. So we have these documents, these documents about frequently asked questions about courses. So here we have, let's take this one, Data Engineering Zoom Camp. This is a gigantic document. You see, this is, was it 300 questions? So these are questions that students who took this course, Data Engineering Zoom Camp, these are the questions that they had. And yeah, you can see like things like when does the course start? What are the prerequisites? Can I still join the course? Things like that, right? So going through this document is not very convenient, even with the search button. Join, maybe, yeah, especially in a course about data engineering, join. We will find many SQL queries, right? So this is not super convenient. So we want to build an agent that is that can index these questions and that can answer these questions from the user, from the student. So these questions, so they are stored in GitHub and they are rendered. So actually, I think we have a link here, right here. So this is a GitHub repo. And in this GitHub repo, am I still sharing my screen? Yeah, I think I am. So in this repo, we have these questions. And then these questions are organized like that, right? So we have a question here. So if we look at the row format of the question, so there is some description of the question. There is the actual question, and there is the answer, right? So what we want to do is we want to parse this, and we want to create a search engine that answers the questions from the users, or first the search engine that gives us the relevant answers, and then an agent that can use this to answer the questions from the students. Okay, so that's the plan. This is what we are going to build. And later, after we build it, I'm going to go over this very quickly. So I assume you already know some things about agents. If you don't, I can recommend you this course, AI Hero. So this is a 7-day small course that, like if you don't know anything about AI agents, you can get up to speed. You can check like how to build a simple agent with this course. And so here in this workshop, we're not going to focus on the internals of how to build an agent. I'm going to just quickly build an agent without going into too much explanation of how this agent works. So I'm going to run now Jupyter Notebook. Also, I need actually, so if I follow instructions, I need my API key. So I actually have this key. So I have the key here. So I use a tool called dir.env. You can install it with pip install dir.env. And whenever you have envrc or .env file with secrets in your folder, it automatically loads this. And of course, we we don't want to accidentally commit this file. So in my case, I have git, I have env.rc, so I want to edit it to git ignore, so I don't accidentally commit it to git. Right. So now I run Jupyter Notebook, and this Jupyter Notebook should have access to all these keys. I only need OpenAI API key. Yeah. Okay. Starting. So while it's starting, let me quickly check. I just wanna see how many people we have. Oh, 30. So hi everyone. Okay, did it start? Yeah, it's still starting. Okay. I don't know why it's so slow. I haven't restarted my computer in a while, so maybe I should have done this before. Okay, so now I'm going to create a new notebook. Let's name it OpenAI SDK maybe. Okay, so now I'm going to so what we need to do now is we need to fetch all the files like that. So I'm going to do exactly that. And what we have in GitHub, it's very convenient. We can actually download the entire repo as a zip archive. So if I click here, download zip, what I get is the entire repo as a zip archive. And now what I can do is I can just go through the files in this zip archive and index these files with some sort of search engine. So this is exactly what we are going to do today. And I already wrote some code for that. So I don't want to spend a lot of time, window. I don't want to spend a lot of time on, what is this? Okay, this is the thing I downloaded, right? So this is the Git repo. So there is some code that allows us to download the zip archive and go through all the files there and process them. And there is some code for that. I'm going to open it. If I open here, so there is some code that we wrote for as a part of this. I showed you this AI hero course. So here in this course, we are dealing with GitHub repos. So this is something we wrote there. And what this thing is basically doing is just downloading this thing as a zip archive, getting this zip archive, going through all the files there. And if the file is what we need, it has the right extension. Also, it matches the some sort of filter we have. Then we load this. So you can go through this. You can ask ChatGPT to explain what is happening here if you want, but I'm just going to use this file and this script, and the script will go to this Datadogs Club /FAQ repo. It will look for all MD files, and if there is data engineering in the path, then it will include it in the response. So what we found is this amount of FAQ entities. So if we look at number 5, let's say, this is the question: how many Zoom camps are in the year, or what can I do before the course starts? So here is our, so I showed you this FAQ. So this is FAQ, but now in Python. But still, this is not something that we can use for actually answering questions from the students. We need to have a search engine on top of that that will allow us to actually do that. So for that, I'm going to use MinSearch. MinSearch is an in-memory search engine in Python. So then once I build an index, again, I will not go into details how exactly it works. There is a workshop called Build Your Own Search Engine, this one that I hosted some time ago, where I explain how you can build a thing like that. I think I will send you, maybe I can send you all the links right now. So I'm trying to find, yeah, chat. Here, AI Hero, and then build your own search engine. So if you're interested in these details. Yeah, but I think, I don't know, it's taking a while, but I think it's just loading the library because it should be rather fast. Anyways, once it indexes this, we should be able to use the search function that will, let's say if we want to get only 5 results, now results 5, then when a user has a question, how do I join the course? We can just use this FAQ index, FAQ search engine that will find the most relevant questions, the most relevant answers to this question, like, well, according to some criteria, right? So these are, in our case, the candidates that will feed into the agent, and the agent will decide what is relevant and what could be used for answering the question from the student. So in this case, our answer would be in the second question. Can I still join the course, right? Oh, it's not exactly, I ask how do I join the course, but can I still join the course? Well, anyways, so this is what we have. This is what the search engine returns. And what we can do now is we can build an agent. And I'm going to use OpenAI Agents SDK. This agent needs tools. So we will have only one tool. The tool is this index. So this tool, I just need to implement a function, which is search FAQ, which uses the index with the query that user passes, and then it will return 5 results. And I decorate this function with function tool decorator. And now I can create an agent. So what an agent has tools. In our case, only one tool, search FAQ. And then it has some instructions. The instructions are your helpful teaching assistant for the data engineering Zoom camp. Your role is to help students by searching the FAQ database and answer their questions, right? So this is a very simple agent, and now we can use it using this piece of code to answer questions. How do I register for the course? And then what it is doing inside, it is using this tool to look up things in the index, and then it analyzes the results, and then it gives the final answer. So if we want to see what kind of search queries it actually, how exactly it is searching for the result, we can go through this thing called new items. We see that there was a tool call, like it tried to use the tool, and the tool was, let me see it, the argument was register for the course. And this tool call output item this is what it returned. Well, there is a lot of extra information, but yeah, we can see that there was some interaction between the agent and the tool. And then finally, there was this answer, right? So this is our agent. So now we have the agent, and now I actually want to make sure we have enough time. So this is our agent. And let's say we built a nice interface, we integrate it into Slack or whatever, and now we start using it. And we notice that people use this agent for things that we don't want them to use, right? So for example, what if somebody asks is, how do I cook pizza? Right? So this is not the purpose of this agent. Like, this is not the reason this agent exists. So we don't want people to just use our agent as a free alternative to ChatGPT, right? Even though you can see that our question is very glad to answer this question, right? So it does not refuse to answer this question and says, yeah, like it looks like I don't have this information in the database, but here you go. This is how you can do this, right? So this is not what we want. So we want to actually detect this thing, and we want to stop the agent, right? So this is the reason why we want to have guardrails, right? And this is the mechanism with which we can, let's say, protect our agent from things like that. So In case of OpenAI Agents SDK, this is the framework we use. Guardrails is actually a part of the framework, so we can see that, so we have input guardrails and output guardrails. Input guardrails run on the initial user input. So our initial user input is how do I cook pizza? So here we want to determine if this is a good question or not good question. So we need some sort of binary classifier that will tell if this is a good question and we should continue, or if this is a bad question, if we should stop, right? So this is the purpose of a guardrail. So we can see that, there are some requirements. So guardrail receives the same input. So guardrail runs alongside the agent. So we run this FAQ agent, and at the same time, exactly when we start, when we send the request to GPT-4o Mini, with these instructions, at the same time, we send the request to our guardrail, and the guardrail will, based on what it sees, it will decide if we should stop or not. Right? And there are some requirements, like we need to the function needs to produce this guardrail function output. Whatever. We will implement that right now, right? We don't need to go through these details. How do we exactly do this? So the simplest way for doing this is to have an agent that checks the input of this of the user and says if this is good or not. And so for that, we will create this base model. I forgot to include one thing, the import. Oops. From Pydantic import base model, right? So this is what our model will output. So it will say whether this input is good or not. So if it's bad, it will say fail true, and it will explain why, right? And if it's good, then we don't really care why. Right, so we need to. So we are going to use structured output. We're going to force the model to output the decisions in this format, right? And our agent becomes quite simple. So this is very similar agent to what we defined previously. So here, this was our agent, but we had a tool here. So the tool we gave access for this agent, we gave access to search FAQ function. But in this case, this agent does not have any tools. So it has instructions. You're a topic guardrail for a data engineering course FAQ assistant. So, and then we describe what exactly it needs to do. And we describe things that are on topic and things that are off topic. And we say output type is this topic guardrail output. So this is the topic output, the output of this agent. So if I now take this code that we have, and I swap it with topic guardrail agent, now we will see that it says it relates to cooking, not data engineering or course topic, which is why fail is true. So if we run this agent alongside our main agent, it would trigger the guardrail and we will stop executing. So now we will see how exactly we implement that. So for that, we need to, as you remember, there are some requirements for this for us to implement. So we need to create this function, guardrail. So I have this piece of code here. Right, so we have this topic guardrail. And what it is doing exactly that, exactly what we did here. So it just invokes this agent with this topic guardrail agent, right? And then user input. And then it gets the final output. And we just wrap this into whatever the framework is expecting. The framework is expecting that we return guardrail function output with output info, our reasoning, and tripwire triggered output file. So I was actually wondering what tripwire is, and I found out that in factories, in assembly lines, when something happened, they had this tripwire, and the worker in the assembly had to like a step on this wire or do something. And when they did this, they triggered the tripwire, and the assembly line would stop. So I was thinking like, well, what is this tripwire, where this is coming from. So the analogy is that when something happened in the assembly line, they would trigger the tripwire and stop the line. Here, we kind of do the same, right? So we stop the execution of the main agent by triggering this guardrail or triggering this tripwire, right? And when this happens, we will see now the agent will simply, so now I'll show you. So the way we do this, okay, we have this guardrail, and I'm getting the same FAQ agent that we had previously, except now I add this new line, input guardrails, which refer to this guardrail. There could be multiple guardrails actually, right? Not just one. So we have this input guardrail, which is a topic guardrail. And now when I run the agent, now this guarded agent, it should raise the tripwire exception, right? So this is how guardrails are implemented. So if this fails, if tripwire is triggered, then yeah, we get this exception, right? And then we need to somehow process this exception. So we need to do something like try except, and then except is do you have, yeah, is, and then I can say, yeah, sorry, well, I actually have the code here. This is what I print because we don't want to show this to the user, right? And then in practice, like when we use something like ChatGPT, yeah, it would see even if it starts typing something, then it would just remove whatever it was typing and it would display this. Sorry, I cannot answer this question. And if you do this through the API would, I think they have this concept of refusals, so they would refuse to give you the answer, right? So then this is essentially this is how we would integrate this into the product. Like if we have the web interface, we just remove whatever the agent was outputting before and replace it with the output from the guardrail. Right, and then for convenience, I put this inside a function. So this is basically the same thing, and we can use it like just use await. Yeah, so this is the same thing. So we don't need to worry about like all these things. Okay, so these are input guardrails. We can have multiple of them. This is not the only thing we can do, right? So sometimes there could be cases, maybe you heard about these stories. There was an airline and the airline implemented a chatbot with LLM and a user convinced the LLM to sell it a ticket, to sell the user a ticket for $1, right? And then the user, they just took the screenshot and asked the airline, hey, like your agent told me that you're going to sell me the ticket for €1 or $1. So now you have to do this, right? So there were quite a few cases like that, especially like 1 or 2 years ago when people only started discovering LLM, AI, chatbots, right? When ChatGPT appeared, which happened a few years ago, right? So there were a lot of cases like that. So that's why we have these output guardrails. We want to make sure that the agent doesn't promise something we don't want to do, or maybe because we cannot necessarily control the output of the LLM, but we can check if this output is good. Maybe what happens is we don't want our LLM to insult anyone, but maybe a user can trick the LLM into doing this by saying, "Hey, we're in a movie," things like that. There are different ways of tricking the LLM to do what you want, even if it doesn't want, and by passing the input guardrails, so at the end they can still somehow trick the LLM into doing what they need. In this case, we want output guardrails. So yeah, here. So the idea is the same. So we have an agent, and in our particular case, yeah, so here are some things that we don't want to have. So we don't want to we don't want the agent to promise any deadline extensions. In our case, only the instructors can do this, not the agent, right? And then you can see like maybe if the agent all of a sudden starts swearing, we don't want that, and things like that, right? Sharing exam answers or solutions. So this is going to be our output guardrail, right? So here we want to, then do I not have the inverse? Okay, yeah, right. Because in our case, we are going to have structured output. Actually, this is the same kind of thing as we have here. So we can just say guardrail output because in both cases fields are the same, right? So we don't actually need to define a new class here. But yeah, I did. So this is pretty much the same thing, right? When it comes to creating it, it's very similar to the input guardrail. The instructions are a little bit different and the way it runs. So in the first case, the input guardrail, we run it on the input of the user. The output guardrail, we run it on whatever the LLM produces. Right, and like if I want to check it, so I can do this. I'll put as FT, and then what a yes, yes, we can extend the deadline. Yeah, now it should, yeah, response promises the deadline extension, which is not what we want, right? And then we simply create again. We put it inside a function, which we annotate with output guardrail, very similar to what we did before. Here. So, but here instead of agent input, we have agent output. The rest is completely the same. Right? And then the annotation is different. And then in addition to input guardrail that we have output guardrail, right? So we basically have these two things. And of course, there could be multiple guardrails. And the thing is, all of them run in parallel. So let's say we have multiple input guardrails here, right? And all of them run at the same time as we do runner.run, right? Question from Pablo: should we also put a guardrail on the input size against SQL injection, or is it handled in another way? Input size, you mean like if the user is putting a lot of things? Well, I guess we can simply, so we have the input prompt, right? And we can check whatever we want with the input prompt even before we pass it to runner.run. We can do that. Or we can also, it doesn't have to be an agent here, right? In input guardrail. So here we run an agent. We run another, we make another request to a model, but it doesn't have to be that. So here we can do something simpler. We can check the size, right? And if we see that the input size is too large, we stop. But I would actually do this even before I send this to our runner, right? So this sort of checks. Because like if we send a very large input to our LLM, it would start processing them and we pay for every token, right? So I would not rely on the framework to handle things like that. I would do some sort of input sanitization before even I put it inside. Yeah, so this is what Pardeep answered. Thank you. Anyways, so coming back to our guardrails. So now we define input guardrail and output guardrail. Here, there could be multiple. And now if I try to run it. So I'm thinking, please extend the deadline. I think I used. I don't think the agent will actually extend the deadline. So I wonder if I do we have examples? Ah, we did. Okay. Output guardrail trigger tripwire. Okay. So here, I guess the agent said, okay, whatever. Here's your deadline extension. Um, and yeah, we just deal with this is the same in the same way. We just do it like that. Right. So here, I think I have this function that now we can use. So I'm simply going to override this. Right. So this is very similar, right? To be honest, I'm not completely sure why they needed to. Yeah, probably the reasons are so imagine for output, the model already output the result. You can see it, and you need to now go back and remove the output and replace it with something else. So the logic here and here could be a little bit different. That's why you want to have this separation. Okay, so these are input and output guardrails. And let me check the time. There were some questions. If you have more questions, yeah, you can ask. Why do we have extra parameters on the guardrails? Context, agent, agent output. Okay, so what we have in the context, we can use this context to understand what has been happening. So this contains any useful information about like our interaction. So for example, here in this safety guard, let me print context. So agent is just our agent. So from here, we can get the instructions of the agent or something else. I don't know. Maybe we can use this agent to get the instructions and say, hey, is what the user asking, does it correspond to the instructions you have? And then maybe we can trigger a guardrail there. So what context has is, I think it's better if I just print it rather than trying to explain. Oh, wait. Give me a font on the course. Okay. Uh, can I get a font? No, can I get, can you give me an extension? And then in this case here in the context, we can also see all the interactions. We can see all the tool calls. We can see the initial user message. This is all available through the context. So we can see that we can see how many requests were made, how many input tokens, output tokens. Yeah, we should also be able to see the messages, I believe. Anyways, yeah. So this is just extra information you might find useful. The most important is agent output, but yeah, there could be some things. Anyways, okay, so this is how you do this in Agents SDK. And as I said, so I like OpenAI Agents SDK. So I think this is a good framework, but my favorite framework is Pydantic AI. And in Pydantic AI, you don't have guardrails. Guardrails. Right, so there are no guardrails, right? Or maybe they implemented this, but I don't see it. Guardrails, Bedrock. So this is not a part of the framework, right? Um, but this is a very convenient and very useful thing to have, right? So in some cases, you might need to end up implementing this functionality yourself. And this is what I do with Pydantic, because I like Pydantic more. With Pydantic, I can use many different providers. I really like the integrations that Pydantic has with Blockfire, for example, and so on. I'm not affiliated with Pydantic in any way. I just like the framework. So, which is why I wanted to also show you how we can implement these things ourselves. And I want to start with a very simple way of doing this is by using tool calls. So here, this is our simplest agent, right? So here we don't have any input guardrails. So this is just our agent, right? And what we can do now with this agent, so our simple agent, we can add an extra tool to this agent. And this extra tool would serve as a guardrail, as an input guardrail. When it comes to the output guardrail, the model returns something, you simply check whatever it returned and then decide what to do, right? So here, you don't need anything special. But for input, it's a little bit more interesting, and I want to implement now. So I'm going to continue using OpenAI Agents SDK. I don't want to switch to a different framework, but all these frameworks, they're kind of similar, so it doesn't really matter at the end what we use. And now I want to use this guardrail agent as a tool. So not as a topic guardrail, not as input guardrail, but I want to create a tool that looks like that, function tool. And then it has a question from the user. So I think I'm going to just copy it. And of course, we need to explain here. I think I will just copy. I have examples here. Check topic, right? So here we just create a function which is check topic, and here we say check if the query is appropriate for this course, right? So that's all we need to do. So we just need to implement this function, and then we have this topic guardrail agent that we already created. And I actually use run. Yeah, like that. So what I will do now is I will just simply create this agent. And yeah, I need topic guardrail output. So I don't necessarily need to recreate this, but just for the sake of completeness, so I will create this thing. Did we already do this? Yeah, we did this. I don't need to define it one more time. So yeah, this thing simply runs the agent as before, and we add it as a tool, check topic, right? And the instructions we had previously, why they're not defined. Maybe I have a typo here. Oh, yeah. Guarded FAQ instructions. So these are the previous instructions, and then I also add the statement before answering any question, please use the check topic tool first. And so this is how I implement guardrails in frameworks that do not support guardrails by simply creating a tool that the agent uses. So the moment somebody asks a question, the agent invokes the tool to see if this is a good thing or not. To see if this is a good input or not. And then we can now, let me copy it. Let me copy this thing, yeah. Can we extend our, how can I copy it now? I think I used the wrong, yeah. So now it's going to, yeah. So if I'm going to go for item in result new items, we can see that there was a tool call. It where do I see? Check. So I think I'm going to use. So I don't want to use this search. I want to use built-in Google search or Chrome search. Sorry. Okay, I'm giving up. But we can see that here, this is actually, yeah, here, check topic. And then it says, here's the output, reasoning. So yeah, reasoning cooking is not related to data engineering. That's why, yeah, sorry. So this is one way of implementing this. Another way would be to actually, so the problem with this approach is first it invokes the tool, and then if this check topic is okay, then only then we invoke the search effective function. And from the user point of view, it may mean extra waiting. So first, the user needs to wait till the model decides to invoke the tool. Then the user needs to wait for the decision of the tool. Then the user needs to wait for the actual thing to start generating the answer, right? So what we want to do is we want to have similar experience to what we had previously with the guardrails, is that we, so in this case here, the input guardrails, when we run the agent, this thing and this thing, topic guardrail and FAQ guardrail, they start at the same time. And if the guardrail is triggered, then we stop the execution. So what we want to do is we want to have something similar. So the user doesn't have to wait for like all this sequential execution, right? And for that, we will need to talk a little bit about asyncio. So you notice that in all these cases, we used await. So here we define the function as async, we use await. So now I want to tell you a little bit about that. So this is a part of asyncio in Python. It means that, so here, what the result of this thing, if we just, so let's say I run this thing without awaiting. So what we get is a coroutine. I'll just call it C, right? And then I can do some stuff here, whatever I want, and then while the function is being executed, and then at the end I just await. So here I can do some things, and then at the end, yeah, I await. So this is the idea behind asyncio. So, but because what I can do is I can run two things. I can run this thing. I can run another thing. And then I wait for C1 and I wait for C2, right? So what we can do is we can run our agent without the guardrail, because in our framework we don't have guardrails. Then we can run the guardrail in parallel. Then we can await for the results. And if we see that the guardrail fires, then we stop the executing of the agent, right? So I'm going to first illustrate this on a simpler thing, and then we will implement something like that. Okay, so let's do that. There's a lot of things. And actually, if you may notice, I accidentally skipped streaming with guardrails. But this is pretty simple. So we just replace run with run streamed, and we iterate over the results, and we don't have to wait till the agent is actually till the model returns the whole thing. We see it appearing as the model starts producing the result. So this is what we see in ChatGPT. Yeah, you can do this yourself, but I will now go to this part 4. Okay. So I want to start with this piece of code. So what do we have here? So here I created a kind of agent. So this is not a real agent. We just simulate that the agent is doing something. So we're sleeping for 2 seconds, right? And when we invoke it, so we wait for 2 seconds and then it's done, right? So this is our agent. And we also have a guardrail. So the guardrail, so if we invoke the guardrail, so now how the result G. So yeah, so it finishes faster. So guardrails need to be faster than the main agents typically. So we sleep only for 1 second. And then if we execute this sequentially, so this is how we do it in case of tool call. So we first execute the guardrail and then we execute the agent. So it's like if guardrail does not trigger any exception, then it's good, we can continue. But here, if we check that it raised an exception, then we do not continue with this mock agent, right? So this is the logic. So then this one is 1 second, this one is 2 seconds. So the user has to wait for 3 seconds instead of 2 seconds for these results. So we don't want to do this. So now we will see how we can run these things in parallel. So for that, yeah, we use this thing called asyncio gather. So what it does is, so it creates this coroutine, and it waits till all the coroutines finish. Right? We can see that they are running in parallel. Guardrail finishes faster, but the agent, yeah, takes a bit longer. So in our case, so this is the order doesn't really matter. Probably guardrail should be first. Okay. Yeah, but what if we have, I should have a different example where we have a failing guardrail, right? So what if our guardrail is failing? I have this example. So what this guardrail is doing is just raising an exception. So if I do this failing guardrail, yeah, it doesn't really matter. Right, so we see the exception. So if I now put it in the original example, I see that there are some questions. I'll check them now, but I want to finish this thing now. So the problem here, if we just do asyncio gather, we wait till both of them execute, and even if this one raises an exception, we still continue executing the agent. So what we want to do is if this one fails or any of the input guardrails fail, then we want to stop the agent. So this is what we're going to do right now. Let me quickly check the chat. Can fully guarded agent have chain list of guardrails and input guardrails more than one? Yeah, I think I answered this question. There could be multiple input guardrails, multiple output guardrails. And we can see, so here, when we, wait, yeah, here we can see which which guardrail triggered it. And if it's multiple, then, yeah, we can also see the results from multiple ones. Will the LLM call this guardrail tool always or only when it's doubtful? Well, it's supposed to call it always, but the thing with LLMs sometimes maybe the user can trick the LLM into not calling it. I don't know. So technically yes, but practically you would need to probably have a good evaluation set where you check that this tool is always invoked, right? So you'll need to do some extra testing. And for people who joined late, yes, the recording will be available, so you will get an email through Maven, and I'll also upload it to my YouTube channel, so you'll have access to the recording. Okay, so where we stopped. So now we have a guardrail that is failing, so what we want to do is, if we detect a failure, we want to stop our agent, right? So for that, it becomes a little bit more complicated. So we need to first create tasks. So not just simply a coroutine, but a task. Because when we create a coroutine, it's not that simple to stop it. So now we want to be able to stop it. We want to be able to stop the execution of the coroutine, and then we invoke. So here, hello. So invoke the guardrail. So we get the coroutine and we turn this coroutine into a task. Right, so then we have two tasks. Actually, yeah, we can see that they are already. Why it's not failing? All right. Okay. Anyways, so yeah, because it didn't return anything. I guess that's why it's not showing. So we create these two tasks, and we do this gather, the same thing as we did before. So I'll execute it in one cell. So we also collect them, and we await till both of them finish. But if there is an exception that is triggered, we cancel the agent. And here is just a convention. Even though we cancel the agent, we need to still await on till it stops, right? So this is like you always have to do this. So we can see that. Do we not have any? I want to have some print statements here. So let's modify it a little bit. So what I will do is failing guardrail, and we'll do this thing. Oops. So this part will never be executed. Okay, so yeah, now we have the logs. So now I started, we see that failing guardrail also started, agent started, and then agent was cancelled because the exception was raised. Right? So what we do in summary is we don't just gather it here, because this way we continue executing, but we turn them into tasks. We put them in try catch, and then we can cancel the agent task, right? So this is how we can implement this. This is all, of course, with toy functions, but now you can simply take this logic and turn this into start using it in your framework, right? And maybe this is what we will do right now. So I have this function. So this is a more complicated function. So we can go through this function now together, and then we can actually adjust our OpenAI Agents SDK code because it uses asyncio. We can use this to run. We just pretend that it doesn't have guardrails implemented, so we are going to use this function to do the guardrails. And actually, I'm not sure if this is exact code that you will find inside OpenAI Agents SDK, but I'm pretty sure that this is something similar. That inside, for all the input guardrails, so it turns them into a task, right? And Yeah, and then it has the agent task, and then it's doing this thing. Okay. So if I now do it run with guardrails, agent. So I will need now, so this is a coroutine, right? Uh-huh. I don't know if we need this thing. Well, I will check now. So run with guardrails. So we await. So first we want to run our mock agent, and then we have two guardrails. Execute. And then guardrail, mock guardrail. And failing guardrail. So let's see if this, yeah, of course, because I don't need this thing here. So we can see that, yeah, so we have two guardrails, mock guardrail and failing guardrail, right? And then all of them were executed in parallel. Then the failing guardrail got triggered, and then the agent got cancelled. Okay, well, at the end, we don't actually have to raise this, but what we see is also maybe we have multiple guardrails and one is triggered before the others. So we need to also cancel the rest of the guardrails that may still be running. Okay, so let's actually try using this function now with our agent. So I'll try to yeah, this is not the formatting I typically use. I just want to make it visually distinct, like where the agent is, where the other things. Runner, run. FAQ agent. And here, I'll just keep these mock guardrails. So yeah, technically, so here we will have what prompt. How do I cook pizza? Okay, so our fake guardrail triggered, so then we stopped the agent, right? And if we actually want to use our real guardrails, I would need to modify this function a little bit. I kind of feel lazy to do this, but what I would need to do is remove this output guardrail, and maybe let's do this. Sorry, input guardrail. Maybe let's do this. So I'll have to copy it. So I'll remove this thing. And I'll have to adjust it slightly. So I want to raise this thing here. So I'm feeling lost. So output. So if wait, if output fail, then we raise this thing. True output reasoning. return, and then we don't return anything, right? Uh, let's check if this works. I actually haven't tested it, so we only need to input. Okay, so seems to work. And if I do, I just discovered the course. Can I still join? So this should work. Cool. So it works. Okay. So I see there are some questions. I'm a bit confused about the role of mock guardrail. So the role of the mock guardrail is what I showed here. So this was we were talking about the scenario where we in the framework we imagine that our framework does not support guardrails. Right? There are frameworks like that. Pydantic AI is one of the examples. There are no guardrails. And I wanted to show you how we can implement guardrails. But first, I wanted to just show you simple toy functions that you don't really need to call anything, right? So that's why we have this mock agent and mock guardrail. So this mock guardrail always passes, and that guardrail always fails, right? And then I was just, executing them, kind of trying to model the scenario where in one case the input is okay, in another case the input is not okay, right? So that's the idea behind these guardrails. And what I wanted, the main thing I wanted to illustrate here with these mock guardrails is the use of asyncio, so that we have this await and gather, right? So because what we wanted to build at the end is a thing that can run our agent in parallel to the guardrails. And if one of the guardrail fails, then we stop the agent. That's why we had this failing and mocking guardrails. I hope it's clear now. If it's not clear, I'm happy to clarify it one more time. When we do LM calls parallel, one for guardrail and one for actual call, are we still wasting tokens? Yeah, so the thing is, the LLM can already start producing output, but then we stop, so we don't consume all the tokens. But also, yes, Augusto is correct. It's a choice between performance and cost. So if you want your user to have nice user experience in the sense that they don't need to wait, then you're spending some money, but then you're kind of, how to say, uh, saving your reputation maybe, or saving you from potential harmful situations, right? So you still spend some money on that. So I am not exactly sure. I would need to check if you stop the execution midway and the agent did not generate all the tokens, if you will pay for the rest of the tokens that the model did not return. I would need to double check. My assumption is you paid only for what you already consumed, but not more. But yeah, I would need to double check. Okay, that's actually everything I wanted to cover today. So I think we already spent more than 1 hour. Uh, um, so, like, if you have any questions, please ask. And what I want to do now is maybe go through the entire notebook and want to summarize what we did. Maybe I also check if I didn't forget anything. Yeah, this function is a bit complicated. So there's also an illustration. I asked an AI assistant to illustrate it. So if you had problems following this thing, check it. Right after the workshop, I will fix some of the errors and commit it. So you will have the updated materials that you can use after the session. So like, for example, this thing here, we don't need. Okay. So I think I covered everything I wanted. So let me now do a summary, quickly go through what we covered. So what we did here today is we talked about guardrails as a way to analyze the user input and analyze the output of the model and see if it confirms to whatever expectations we have about that. And if they don't confirm, the input doesn't confirm, or the output doesn't confirm, con, conf- yeah. So like if it doesn't follow our expectations, then we simply do something, right? So we can remove this output or do something. So what we did here is we created an agent that responds to the questions from students using the FAQ data. So we downloaded this data from a GitHub repo. We indexed this data, we put this into a search engine, and we created a simple agent that is doing this tool that can use this search engine to answer the questions, right? And then we were thinking how to avoid situations then the user could misuse our application for questions that they are not supposed to ask, right? And this is how we came. This is what the guardrail solved the problem that we had, right? And this was the case for input guardrails. So we can control the topics that are okay for the agent, for the users to ask to our agent, and the topics that are not okay. So we would put this logic into the guardrails. And then we also implemented an output guardrail. So about things that we don't want the model to output, but we all know that LLMs are not deterministic. So sometimes they may output something we don't want. We don't want them to output. So that's why we have output guardrails. So we put everything together. In this particular case, we used OpenAI Agents SDK, which has the this built-in functionality for guardrails for input and output, but not frameworks have them. And or maybe at work you have your own framework. That is also the case for many companies. They have their own homegrown framework. Yeah, maybe it doesn't have guardrails. So then we also looked at how to implement these guardrails. So we looked at asyncio. We looked at turning these coordinates into tasks. And if one of them throws an exception, we looked at how to stop the other task. In our case, this is the agent task. So then finally, we put everything into one function. And what I'm going to do now with this notebook is I'm going to actually put it here. So you will find this notebook here in this workshop. So I will also add a link to the video once it's uploaded, and the notebook will be here. So if you're watching this in recording, you can just go there and check it. So that's it for today. Thank you. Yeah, and speaking, thank you, Augusto, for nice words. Speaking of the next session, actually there is one. So I think if we go to Maven and this link, you can see all the things that are in pipeline. Right now it's just one. So this skills AMD from scratch. I'm going to share a link with you. So if you have not seen this, you can sign up. So what skills MD is a concept from Anthropic, from Claude, where you can describe things that LLM is supposed to do in MD file. Yeah, I'm going to show how these things are implemented, how these things work under the hood. So we already did a coding agent. And actually, if you plan to attend this session, I recommend to check this one, build your own coding agent, because we're going to build on top of that webinar. Of course, I'm going to do a small recap at the beginning. And then we created our own coding agent here, and I'm going to add the skills capability for this agent. So let's say we want to teach our agent to properly use UV. So typically LLMs cannot do this. So at least in my experience, they try to use UV peep and things like that. This is not how I want the agent to use UV. So I can create a skill that shows the agent how exactly it should use UV. So then it will follow these instructions from this MD file. So this is what we will do next week, I think in exactly 1 week's time. So if you're interested, check it out and see you there. So thanks a lot. And can I share the screen? Stop sharing the screen. Yeah. So bye, everyone. Thanks for attending.